Hey, in this example we're going to find the volume of e to the x when it's revolved around the y-axis, and our limits on the x-axis are 0 to 1. So let's take a look. You see here's e to the x, and we're going to revolve it around the y-axis, and it will form this sort of bowl, cone sort of thing. Not sure what you call it, if you call it anything at all, but here it is. Alright, so let's get started. So step number 1 is to rewrite this as x equals. So we'll start with y equals e to the x. We'll start solving for x by taking ln of both sides. Okay, bring the x down. So we have ln y equals x, and then ln of e is 1. So that means x equals ln y. Step number 2 is to deal with the limits. These are on the x-axis. We need them on the y-axis, so just plug in 0 for x. There we get e to the 0 equals 1, and then plug in 1, we get e to the 1 equals e. So these were our old limits on the x-axis. Now these are our new ones on the y-axis, corresponding to the same points, of course. Alright, so now our integral is going to be pi r squared. So pi from 1 to e of r squared, our radius squared. So that's ln y squared dy. Alright, to do this, you're going to need integration by parts. So we'll let u equals ln y squared, and du is equal to 2. Bring down the 2. ln y, the inside stays alone. Divide the derivative, or multiply by the derivative of the inside, which is 1 over y. So I'll divide by y, and dy. dv will let equal to 1 dy, which means v is equal to y. Now our check mark. Here's our check mark, which tells us the formula. So then we have uv minus the integral of v du. So that's y ln y squared from 1 to e minus integral of v du. I'll pull out the 2. The y's will cancel, and I'll be left with ln y dy. Alright, I'm going to leave this part alone. What I'm going to do now is I'm going to do integration by parts again. So I'll let u equals ln y, and du is equal to 1 over y dy. dv will let equal to 1 dy, which means v equals y. Okay, now this is the part you need to keep very organized. So y ln y squared and minus 2 parentheses uv, so that's y ln y, minus the integral of v du, so that's the integral of just 1 dy. Okay, so this is from 1 to e, this is from 1 to e, and this piece is from 1 to e. I'm not taking the integral now, I'll do it all at the same time later. Okay, so the integral of 1 is just y, so now I'll rewrite this whole thing. Y ln y squared minus, distribute this 2, we get minus 2y ln y, distribute this minus 2 here, and we get plus 2, integral of 1 is y. Okay, and this is from 1 to e. substitute in e, we get e times 1 minus 2e plus 2e minus, substitute in 1, ln of 1 is 0, ln of 1 is 0, and this should just be 2. So to me, this looks like e minus 2. And of course, we don't want to forget our pi, which means it's actually pi e to the minus 2.